Okay, so here's some extra practice for 8-1. If you look on page 94, try these A, there are 3 problems that we can work. Now, I skipped the first one that says, how do you know that the solution is reasonable and correct? It's referring back to example A, and basically we know that it's correct because 9.416 in example A is greater than or equal to 1 and less than 10. So basically our answers need to be equivalent to item 2A if you look at the steps there in example A. Now I worked example A very differently than the Springboard book explains. I mean, the work is the same, but my explanations, we talked about a teeter-totter, like if one side goes up, the other side has to go down. We talked about just taking the digits and grouping them together before we multiply. So I just use a little bit different language that I think is a little more user-friendly. Sometimes your Springboard is so proper in their mathematical language that it gets a little bit tricky. So I'm skipping that one. So we're starting with B, which says 9 times 10 to the 5th power times, when they're next to each other like this, is multiplication, 3 times 10 to the 4th power. So remember, the first thing I need to do is multiply my digits. So I'm just going to group them. I'm able to group these because of the associative property and because of the commutative property. I hope my pencil is showing up okay. I usually write in color, so this is a little strange on the screen here. But anyway, I'm going to take the digits that are given to me, multiply those together, and then I'm going to have a times 10 number, but I'm going to go ahead and find out what that number is going to be by grouping my tens to the powers together over here. So again, if I take 9 times 3, I know is 27, times 10 to the, now my bases are the same, so I'm able to add the exponents. So 5 plus 4 is 9. Now this is not scientific notation because my number is not between 1 and 10, so I have to go ahead and regroup this here. So here's my decimal point right now. I need to move it here, which will make it 2.7. So here's where my teeter-totter comes in. If I went from 27 to 2.7, I made the number smaller on a number line. So that means if this one got smaller or went down, right, in value, then this one needs to go up like a teeter-totter by the same amount. So this one over one place, this needs to go up 1 digit. So that means 10 to the 10th power. Okay, and that's my final answer for that one. So over here, let's go to C. It's same multiplication. I'm going to go ahead and multiply 1.6 times 3. And I'm going to have 10.8 times 10.4, 10 to the 4th, 10 to the 8th times 10 to the 4th. So I'm going to get my calculator for this because, I'm not really excited about doing this double digit here. And we're allowed to use our calculator. So 1.6 times 3 is 4.8. And then I'm going to have times 10. And then I have same base, different exponents, add them. So 8 plus 4 is 12. And this happens to be in scientific notation. It is between 1 and 10, and I am good to go with that one. So next, I'm going to take my digits and still multiplying. Everything about this process is the same. I'm repeating myself. Okay, so all I'm doing is regrouping my numbers here, so I'm multiplying them the way I want to. 4 times 6, we should know the answer to this is 24. And then I'm going to have 12 plus 5 is 17. Okay, so my process is being streamlined here, but again, my decimals here, which is 24, is greater than 10, so I need to make it move. So since I made that number decrease, I need to make this number increase, like my teeter-totter. Okay, so that's on page 94. Now, I thought there was a try these B, that's why I have it scribbled out, but there is not a try these B. But we didn't get through all of the check your understandings in class, so I'm going to go ahead and do those on page 96. So here we have some division thrown in. If you remember, I'm just going to group them this way. So this reads, it's a fraction, but it reads 6 divided by 3, which equals 2. Now I'm going to have my times 10 to the sum power. I'm going to group these two together. Remember, my bases are the same, so I can subtract. Numerator, subtract, denominator is 1. So I'm done. That is the whole problem right there. Okay, now down here, this is scientific notation, by the way, because this number is between 1 and 10. Now we have another multiplication problem. We've done 3 already, so this one I can kind of run through. The only difference with this one is I've got a negative number, right? So that negative number is going to mean I have a negative exponent when I'm done, because negative times the positive. Oh, wait, I'm not multiplying exponents. Okay, that's where you all are going to make your mistake, the same place I just did. First, let's multiply 3 and 2. Bases are the same. I add the exponents. So what is negative 5 plus 4? Is negative 1. Okay? So please be careful. Just because there's a negative exponent, my rule about what to do doesn't change. Just my value looks funny. So this is scientific notation because 6 is between 1 and 10. So I can keep going. So here I have 4.2 times 3, and then 10 to the 8th times 10 to the negative 5th. Okay, so again, I'm going to grab my calculator for the decimal. So 4.2 times 3 gives me 12.6. Okay, and then I'm going to add, so 8 plus negative 5 means I have 3. Okay, if you're not sure, you can put that in your calculator. We should be better at integers, but if 8 is bigger, that means my number better be positive, right? 8 is bigger than 5, so my number will be positive, but I'm going to do that as subtraction. Okay, but again, my answer is not in scientific notation. I have to go ahead and change. 12 is greater than 10. So that gives me 1.26. So this number went down. This number has to go up times 10 to the 4th. So that is the answer to number 8. So let's do another division here. This time I have 3.2 divided by 4. Well, I don't know what that is. So I'm going to put that in my calculator. Actually, I do know what it is, but you may not recognize it because there's a decimal there. So my answer is 0.8. So 0.8. And then here I've got dividing numbers that have the same base, different exponents. 5 subtract 9. So 5 subtract 8, which is going to give me negative 3. Now, this is not scientific notation. I need to move this number over to give me 8 times 10. This became a bigger number. 0.8 to 8 is increase, so this needs to decrease, which means I'm subtracting 1. Okay, if you said, yes, it needs to decrease and then put negative 2, you increased it. Remember when we talked about the thermometer in class? So if the temperature outside is negative 5, and at lunchtime it got to negative 1, I actually increased my temperature, so it's warmer outside. So that's how I remember. You can also look at a number line and see, am I getting, as I move to the right, I'm increasing my value. As I'm moving up the thermometer, I'm increasing the temperature. So thermometers are good for me to help me remember that when I need to decrease, my negative number actually looks like a larger number, but I'm becoming more negative, which is colder, right? We'll be there soon enough. All right, thank you, and I will see you all in class.